The topic is Box and Whisker Plot, or box plot. Another name for a box and whisker plot is a box and whisker graph, or obviously a box plot, okay? So those names are all interchangeable. I just wanted to introduce you to all those possible names because I'm not sure how it'll be presented to you on assessments or other textbooks. The essential question is, can you interpret the data displayed in a box and whisker plot? So right here I have a box and whisker plot, but before we go into labeling the parts of it and the key ideas behind it, I want to go ahead and just show you how to create one, okay? You don't have to create one, but you do have to listen to me. So right here, these are some numbers, and when they give us some numbers, we call it a data set, okay? These are the numbers they give us to work with, and someone else can collect them through surveys or scores or something. So this could be like the number of people that were answering a survey in several cities and their responses or something like that, okay? So bottom line is it's some data that they just give you. Now to create a box and whisker plot, the first thing you got to do is order your data from least to greatest. So right here I see that there's a 2, so I'm going to just put them in order. Least to greatest. Okay, so we have 2, we got 5, then we got 8, and then 10, then 12, then 20, then 100, okay? The next thing after that, you want to find the median. So now we find median. Find the median. Median means the middle number, okay? Median is the number that's in the middle. So I'm going to kind of cross them off. Okay, so our middle number is 10. Okay? And you're probably like, why did you just do that? Well, this is why, because that's the median. And then from there, I'm going to just kind of cover up all those. I'm going to find the median of this right here, and the middle number is right here. Okay, and then cover up this side from the median, and our middle number is right here. Okay. All right, after we've done that, then I'm going to go ahead and create a number line. So I created a number line. I am counting by 5s. That's the intervals. So I went from 0 to 115. I'm jumping by 5s. And here's how we would begin to construct our box and whisker plot. I'd probably put down the median first. So the median was 10. So right here at 10. I'm going to put that right there, like that. And then 5 is the lower quartile, so I'm going to put that right there. And my lower extreme is 2, so 2 is about right there. And now for the other side, we got the upper quartile is 20. And our upper extreme is 100. From here, I'm going to go ahead and create the box and whisker plot by connecting this like this. And then here's a whisker. And there's a whisker. Okay? So you'll see how our data is evenly divided up here. And down here, it's got more of a spread from there to there. Okay? And I'm going to explain the significance of that from our notes. So that was how we created a box and whisker plot. They give you the data, you put the data in order from least to greatest, you find the median, then you find the lower quartile, which is the median of the lower half of the data, and then you find the upper quartile, which is the median of the upper half of the data, and then these two guys at the end are the upper extreme and the lower extreme. Now here's a box and whisker plot with a different set of data that was used. The thing I want you to write down right now is probably one of the most important parts of a box and whisker plot. Okay? So we're going to put an asterisk next to it because this is a key thing I want you to know. Each of the 4 sections so each of these 4 sections, 1, 2, 3, 4, they represent, each of the 4 sections represents 25%, or, well, 25% as a fraction is 1/4 of the numbers in the data set. Okay, so let's go ahead and represent that on here. So from right here to here, that little section, that's 25% of the data, or 1/4 of the data. So the numbers that they give you, 1/4 of them are in this little range right here. Okay, and then from this little section right here to this little section right there, that's also 25% of the data. And then this section right here, from there to there, is also 25% of the data. And from here to here, that's 25% of the data. Remember, the data is the numbers that they give you. That was collected from an experiment or from a survey. So if you're like, gosh, this is 25% of the data and then so is this, why is this so long right there? Here's why. The numbers that are represented in here are more spread out, okay? There's still the same number of pieces of data right here as there is right here, but these are more spread out than these. So tell me, what do you know about the numbers in this 25% of the data? Are they really spread out, or are they really close together? Well, those would be really close together. See how these right here, they are very spread apart. So in my box and whisker plot, see how they're very spread apart. See how these guys right here, they're pretty close together. Right here, they're pretty close together, okay? This is still 25% of the data here, 25% of the data lies in that section, 25% of the data here, and 25% of the data is in that section, okay? All right, now let's go through and name each of these sections. So you'll notice that this box and whisker plot doesn't look like the one I just showed you. There's a couple ways that you'll see box and whisker plots. They'll typically have the box like this, but sometimes in the whisker part, they'll have just dots. The one that I drew you'll see that I used like lines like that. Same thing, they're both box and whisker plots, okay? You'll see a variety in how they look. Okay, let's go ahead and label the parts of this box and whisker plot. So that one number right here, right in the middle, that's called the median. That's the middle number in your set of data, okay? Now let's look at this number right here represented right there. That's called the minimum, or they also call it the lower extreme. It'd be the minimum number in your set of data, or they call it the lower extreme. Lower extreme. Okay, those are interchangeable. Now let's go ahead and look on the other side of your box and whisker plot. This right here, just like this was the minimum, this over here is called the maximum. Or they call it the upper extreme. Okay, then this part right here is called the lower quartile. There is called the upper quartile. Okay, take a second right now and memorize the names for each one of these sections, okay? You should also memorize that each of the 4 sections in a box and whisker plot represents 1/4 of the data, or you could also say 25% of the data. When they are closer together like that, that means the data, the numbers in the data are more close together. When it's more spread out like that, that means the numbers are more spread out, but there are the same amount of numbers in each one of those little sections. Okay, the next one. And the question says, what percent of the data is at 60 or more? So here's how you need to be able to read a box and whisker plot. Look at 60 or more. That's the key word, 60 or more. So you see your number line, you're going to find 60. There it is. You're going to cover that up. What percentage of the data is at 60 or more? Well, that's 25% of the data. Okay. What percentage of the data is 60 or less? Well, look at 60 again. 60 or less. Well, there's 25% plus 25% plus 25%. 25 plus 25 plus 25 percentages is 75%. Okay, now it says what percent of the data is 35 to 60. So if it helps, you can use that something to cover your paper with. You got 60 and we're looking at 35 right there. Oh, so here's a section here that's 25%, 25%, 25 plus 25 is 50. This is 50% of the data. Okay, now it's asking us to find the range of the numbers in this data. Well, the smallest number, which is the minimum, is 10. The highest number, which is the maximum, is 90. So to find range, you just take your max, also known as your upper extreme, and subtract your minimum, which is also known as the lower extreme, and that will give you the range. Okay, so go ahead and look at the information, and you would take 90 minus 10. So your range is 80. Okay. The next one is maybe a word you're not familiar with, and it's interquartile range. So I want you to take a second and think about what the heck is an interquartile range. We already found the range, which was the highest minus the lowest. So the interquartile range. Look at those words. Your key word right here is quartile. Okay? So to find the interquartile range, you would take your upper quartile, subtract your lower quartile to find the interquartile range. Okay, so let's go ahead and get the information from the Box and Whisker Plot. So our upper quartile is at 60. Our lower quartile is at 35. So we need to go 60 minus 35. Our upper quartile is 60. Our lower quartile was 35. 60 minus 35 is 25. Our interquartile range is 25. Okay. For your summary, I want you to answer this question. And I'm not going to write it down because I want to know who's listening to the video and who's not. For your summary, I want you to summarize how to find the range and how to find the interquartile range from a box and whisker plot. This example says the local utility company released a report showing the August electric bills of their customers. This box plot shows the results. So we got a lower extreme of 160. We have got an upper extreme of, let's see, we're counting by 20. So our upper extreme is 260. Our median electric bill, so the middle number in all of this data, is 200. Our lower quartile is 180. Our upper quartile is 220. So you're going to answer these questions on your own. And if you're confused at all, you're going to flip back to the front page of these notes and figure it out, okay? What is the interquartile range? What is the upper extreme? What percent of the bills were $160 to $200? What is the range of the bills? What percent of the bills were $180 or higher? What percent were less than $160? Okay, what percent were less than $160? And last, for your summary, what is the median? Gavin and Colton were filling out an online health survey where they had to indicate how much time they spend exercising each day. These box and whisker plots show the results. So you'll see we have two box and whisker plots on the exact same number line. They often do this when they're comparing two different sets of data. And in this case, you have a set of data for Gavin and then a set of data that represents Colton. And it represents their daily time spent exercising in minutes. So for example, the least amount of time that Colton spent exercising would be 10. If you're like, how'd she get 10? I'm looking at the intervals here. So we go from 20 to 40, so down here is 30. So I'm jumping by tens. So whenever you have something like this, you might want to just fill it in to avoid confusion later on, okay? All right. The summary at the very end is, what will you remember about solving this problem that will help you with similar problems in the future? So you're going to answer this question. So I'm just having you pre-read that so you can think about it as we work through these problems. It says, how much greater is Colton's interquartile range than Gavin's? So we need to find the interquartile range for each boy. So I'm going to go ahead and find Gavin's interquartile range. Oops. And then I'm going to abbreviate interquartile range with IQR. Okay, that means interquartile range. That's Gavin's. And his interquartile range, remember you got to take your upper quartile minus your lower quartile. The upper quartile is 80. Minus the lower quartile is 40. 80 minus 40 is 40. Okay? Now for Colton's interquartile range. Again, you take your upper quartile for Colton this time. It's 70, and we're going to subtract the lower quartile for Colton, which is 20. 70 minus 20 is 50. So it's saying how much greater is Colton's interquartile range than Gavin's. So Colton's was 50. And Gavin's was 40. 50 minus 40 is 10. That's our answer. Okay, the next question says, who has a higher median? So I want you to do this one on your own. Remember which one represents the median on a box and whisker plot. And if you don't remember, then I want you to refer to that front page right here, which one would be the median, okay? Who has the higher median? The next question, who has a lower range of their data? So we got to find the ranges of each of the boys. And to find range, if you don't recall, is going to be on the front page right here. You take your maximum minus your minimum. Or you could take your upper extreme minus your lower extreme. It's the same exact thing. Okay? So who has a lower range of their data? So for Gavin's range, Gavin's maximum or upper extreme was 100, and his minimum or his lower extreme is 20. So 100 minus 20, which would give Gavin a range of 80. So for Colton's range, go ahead and do the exact same thing. Find Colton's upper extreme and subtract the lower extreme, okay? And then you'll get his range for his data. And then to answer the question, you just write a sentence. Okay, the next question says, who has a higher lower extreme? So looking for a higher lower extreme. So I'm going to look at the box and whisker plots and just pinpoint the lower extremes. So the lower extremes are also known as the minimum, and that would be right here. So for Gavin, his lower extreme is 20, because I'm just looking at the dot and then going straight down. Colton's lower extreme is 10. So the person with the higher lower extreme is Gavin, because his is higher than Colton's. Okay, the next question says, who has a lower upper extreme? So we want an upper extreme, and from here, our upper extreme is also known as the maximum. It's the one right there on a box and whisker plot. And we're looking for the lower one, the lower upper extreme. So here's an upper extreme for Gavin, which is 100, and here's the upper extreme for Colton, which is 90. And we're asking for a lower upper extreme, that would be Colton. Make sure you understand that, okay? So don't forget to answer the questions that we didn't cover in the video, as well as answer this summary. What will you remember about solving this problem that will help you with similar problems in the future? Please don't slack off when you answer this question. These box and whisker plots show data regarding attendance at some schools. So we've got Longview, Larson, Lakeview, and Garden Heights' attendance data represented in these 4 box and whisker plots. And you'll see it's presented a little bit differently than what you're used to. So what could help is if you turn your paper like this and read it this way, okay? And you'll see again, these box and whisker plots look slightly different than ones you've already seen in the notes. See how this was the previous problem you've done, and right here they kind of have that little like line segment going on. That's just a different style. It means the exact same thing, okay? So this right here is still the lower extreme, upper extreme, median, upper quartile, lower quartile. So anyway, to answer the questions, it's asking us which school has the lowest median. So we're going to go ahead and look at the data here. Well, Longview's median is 4. Larson's median is 7. Lakeview's median is also 7. Garden Heights' median is 5. So go ahead and answer that question. Which school has the lowest median? The next one asks, which school has the lowest lower quartile? Oh, so we got to find the lower quartile of each one of them. That's what we're going to focus on, the lowest lower quartile. Okay? So the lower quartile for Longview is 3. Larson's lower quartile is 4. Lakeview's lower quartile is 6. Garden Heights' lower quartile is 2. So you need to find which school has the lowest lower quartile and write it down. The third question asks, which school has the highest lower quartile? Okay, so again, we're going to be looking at that lower quartile of each of the school and seeing which one is the highest. Okay, go ahead and write that down. Which school has the lowest interquartile range? So to find the interquartile range, you would take your upper quartile, subtract your lower quartile, and you're going to do that for each one of the schools, okay? So I provided some room up here to help you do that. So I'll help you with a couple of them, but then I do want you to finish this on your own. So to find the lower quartile for Longview, it is 3, and its upper quartile is 7. So to find the interquartile range, I need to go the upper quartile of 7 minus the lower quartile of 3, 7 minus 3 to get 4. So the interquartile range for Longview is 4. Okay, now I'm going to help you find the interquartile range for Larson. So to find the interquartile range, you take your upper quartile of 8 and subtract your lower quartile of 4. 8 minus 4 will give us the interquartile range for Larson. Okay, now do the same things for Lakeview and Garden Heights. So Lakeview, look at Lakeview, take its upper quartile, go all the way back up, minus its lower quartile, go all the way back up to your number line to find its interquartile range. Same with Garden Heights. Take its upper quartile, minus its lower quartile to find the interquartile range. Then you will answer that question. Which school has the lowest interquartile range? Check and see which one's got the lowest, okay? And that will be your answer. And for the last question, which school has the lowest upper extreme? Which school has the lowest upper extreme? So if you're curious which one is the upper extreme is this point right there. And you're going to find which school has the lowest upper extreme, okay? Who's got the lowest upper extreme? Write that in. For your summaries, I want you to answer this question. Yes, write it out. Which section of a box plot each section of a box plot represents blank percent of the data. So each little section right here is what percentage of the data. So from here to here is what percentage. 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 Okay? And last but not least, I want you to label this box and whisker plot. So right here is what's that called? And what's this point called? And what's this point called? And what's this one called? And what's this one called? Okay, label that. Have a good day.